So in order to determine the perimeter, what we have to do is we have to add all of the distances around the shape, okay? So we're gonna go around these shapes and add the distances, but we're not gonna go through the shapes. And I'll show you what that means when we get to it. And to determine the total area of a composite figure, we're gonna either add or subtract the areas of the separate shapes. So we're gonna add them if the two shapes are added to each other. They're combined, and we're going to subtract them if one shape is actually taken out of the other figure. So for these examples, calculate the perimeter and area of the following composite figures. Okay, so first, area. So for this shape, the triangle and the rectangle together, it's quite easy. So we're going to add 4.5, 4.5, 8.2, 5.5, and 8.2. Okay, this is a rectangle right here. So this side and this side are going to be the same measurement. They're going to have the same measurement. Plus 4.5 plus 8.2 plus 5.5 plus 8.2. Okay, and when we put that into our calculators, 4.5, 4.5, 8.2, 5.5, 8.2, I get 30.9. So the perimeter of this shape here is 30.9 meters. Okay, now the area, a little bit more difficult. Okay, so we're going to find the area of this shape. So let's just call this shape 1. Okay, and then the triangle. So the area of a rectangle is easy. It's just length times width, and we have those two measurements. Okay, 8.2 times 5.5. Okay, quite easy. When you put that in your calculator, 45.1. And that's measured in meters squared. Okay, now in regards to the triangle, remember when we're finding the area of a triangle, it's area equals half the base times the height. And the base and the height here meet at 90 degrees. So this is going to be the base, and we know what the base is. The base is 5.5. Okay? So half the base, 5.5. But we don't know what the height is. So we actually have to use Pythagorean's theorem. So let's take one of these triangles. The hypotenuse is 4.5, and the base is actually just going to be half of the 5.5. So 2.75. Because since this is isosceles, the 4.5 and the 4.5, this is going to be 2.75, and then this is going to be 2.75 as well. Now, we have to find the height. So let's get red. Okay, so let's do a squared plus 2.75 squared equals 4.5 squared. Bring this over. A squared equals 4.5 squared minus 2.75 squared. Okay, so 4.5 squared minus 2.75 squared, I get 12.6875. Root both sides. Okay, we learned this in section 8.1. I get 8 equals 3. Let's do one decimal. 3.6 meters. Okay, so the height here, 3.6 meters. So the area of this triangle, back to blue. The area of this triangle is going to be 1/2 5.5 times 3.6. So 1/2 times 5.5 times 3.6 is 9.9. But we only calculated this triangle. We need to multiply this by 2 in order to take into account the other half of the triangle. So area of the second figure is 9.9 times 2. And we get 19.8 meters squared. Okay, Now, all we have to do is add the areas. So area of the entire composite figure is going to be the area of object 1 plus the area of object 2. So the area of object 1 we said was 45.1 meters squared. The area of object 2 is 19.8 meters squared. So the area of both of them is 64.9 meters squared. And I'll do B on the next video.